Welcome to the lecture series Programming in C, in which we will be learning about variables and data types. We will be learning how variables can be named, how it can be declared in the program, and how we will be able to use it as variable in a program, and how variables can be assigned with values. Taking forward, how we are going to name a variable. What is a variable? A variable in C will be having the same meaning as a variable in algebraic expressions. In algebraic expressions, we will be using the notations as alphabets like x equal to a plus b or z plus 2 equal to 3 into y minus 5. The similar way the variables are even used in C language, but there is one small difference that in algebraic notations we will be using only single alphabetic character, but there is a way of using or defining variables in C language. So, we will be focusing, we will be learning on it. So, what are the things that should be followed, or what are the norms that should be followed in defining a variable in C? So, let us see how variables should be defined. The first point is may only consist of letters, digits and underscores. The name should start only with a letter, followed by it can have a digit or any special symbols, especially the underscore, and the length of the variable name in C language should not exceed 31. There can only be the maximum of 31 characters in a variable name, and it should not begin with a digit. Also, it should not be a C reserved name. We have got a set of C reserved names. We are not supposed to use or name a variable with the keywords of C language. There is a set of 32 keywords in C language. So, those keywords we are not supposed to use it as a naming variable. Then we will move on to the part of how variables can be declared in a program. What are the ways that we are supposed to declare and what supposed to be followed? The first step to be followed is, in variable declaration there is a specific name allocated for the variable. Also, there is a specific memory location allocated for the variable with a unique address name. Say for instance, if we see a variable named number of days, if you want to declare a variable to store the number of days, I am just declaring it as no underscore days, in which we will be able to store some integer values. Of course, the memory location will be uniquely assigned for this particular variable name. Say for instance, no underscore days, it is a variable which is actually allocated with a specific address, but the value is not being assigned to that variable. So, hence it stores some garbage value in that particular location when it is assigned to a variable. Generally, in C program, in whatever the program we write, the program on compilation will be generating a symbol table. The symbol table will have the mapping between the variable name and its unique address. Say for instance, if I am having a set of variables defined in a program, say for example, if it is going to be integer, I am declaring the variable named a, which is of integer type. Then in the symbol table, with respect to the variable name a, there will be a unique address assigned. Say for example, let me assume that address to be say 5052. So, the value of that variable will exist in this address. So, the compiler is being given an instruction that the variable a is assigned or mapped with an address say 5052. In that particular memory location 5052, you can find the value of a. If it is not assigned in the program, it remains a garbage value. it remains some random value which is already existing or which is not cleared in that particular location. So, what happens here, when I use the variable name A, immediately the compiler will be able to identify the value of that variable from the given address. So, when it is assigned with an address 5052, so when I use a statement, say for instance say printf %t comma a. So, this statement is used to print the value which is stored in the variable named a. So, what actually the compiler does, when it encounters the name of the variable here in the printf statement, immediately it will be going through the symbol table. In the symbol table, it will find the mapping of the particular variable name with the corresponding address. So, when it is able to fetch this particular address, the compiler will now be able to get into the corresponding memory location and then it can fetch the value which is stored in that particular location. So, it immediately finds the memory location 5052 and then it is now checking what is the value that is stored in that particular location and it will be able to fetch that value and that value will be displayed through the printf statement. This is what actually being carried out in a C compiler. So, why we need to declare a variable? Okay, by declaring the variable, the user is instructing the compiler that this particular variable can be accessed with a corresponding unique address, memory address, and from that memory address the value of the variable is accessible. So, that is why we do the variable declaration process for each and every variable we use. And how to declare a variable? There are certain things that should also be known before or while declaring the variable. There is a term called data type. Say for instance, I am asked to write a program to use two numerical values. Okay. One program is to calculate the sum of two numbers, or the other program is to calculate the exponential or logarithmic value of two given numbers. So, in this case, for the first exercise, it is enough if I go with the number set from 0 to 100. If I have to calculate and check the sum of two numbers between 0 to 100, it is enough if I use the number set between 0 to 100. Whereas, in a case of exponential calculation, logarithmic value calculation, we need large range of numbers for operation. So, the compiler will be able to differentiate the memory space required for storing the values. Say for the first case from 0 to 100, it requires at the maximum, say if you are calculating through 2 power n, it requires only at the maximum of 16 bits, because with 8 bits we will not be able to support. With 8 bits it can go up to 256 values. Even with 8 bits also it is fine. Whereas, in the case of storing exponential and logarithmic values, we may need more than 32 bits for storing and adding or computational methods. So, in this case we can explore and we can understand that every variable is dependent, or the size of every variable is dependent on the requirement of the application or a task. So, depending on the task, we can define or we can declare what is going to be the size I require for storing the particular value in a variable. So, altogether we can come to a conclusion that every variable need not be defined with the same size. So, we need different sizes of variables for different applications or requirements. So, based on that, C already have defined certain data types, using which we will be able to distinguish that based on what the requirement, what sort of data type can be used for declaring a variable. So, on the aspect of that, C uses three major data types called integer, floating point numbers and characters. For integers, it uses some modifiers. Generally, if we say as int, the basic int data type, the size is going to be fixed value. So, the size of the integer can be varied or can be modified based on the modifiers we choose. The modifiers are long, short, signed and unsigned. So, if I say it is short, by the name it is very easy to understand that if we want to reduce the size of int type, we can go for short. If you want to expand the size, we can go for long. If you want to do some modification with respect to the sign, in the sense that we can declare the positive numbers and negative numbers. With respect to unsigned, we can make both positive and negative numbers to fit into the same range. Okay. By doing so, we can get the data type size to be increased rather than we can have if we are having it as signed. But for some applications, we may need both positive as well as negative numbers. So, in those aspects we can go for signed int. So, similarly, the floating point values can be defined using two major data types called float and double. Again, we have one more modifier with respect to float, which is called long double. With respect to char, char is used to store a single character, and with respect to char also there are two modifiers possible called signed and unsigned. We will see how actually we are going to use those variables in our program. So, the major classification of data types with respect to integer, the short type is between 16 bits and which is greater than the size of char. The size of char will be of 8 bits. We can declare this short type as short int, signed short int or signed short, in any way you can declare. Generally, if the size of the integer type, if it is going to be 16 bits, I can go with the number range from minus 32,767 to 32,768, which includes the values in the range 2 power 16. So, this is how the short int handles the values from minus 32,767 to 32,767, including 0. There is a way that this can be done, I mean it includes both negative as well as the positive range. So, this can be still more reduced, or the size, the range values can be increased by just making the negative values also to be in the positive range. If it is done so, this minus 32,767 to 0 can also be added with 32,767 positive value. So, we will be able to get the range from 0 to 65,535. So, which is again 2 power 16. So, here we are not changing the size of the variable or size of the data type, but then we will be able to modify the range of data that can be stored using that data type. Say for instance, if we are selecting the short as the data type, which includes both negative as well as positive values. So, if I want an application which requires both positive and negative numbers, I can go with declaring it as short int or signed short int. Whereas, if I do not want, say for example, I am going to declare the variable for the use of register numbers or roll number of a student or Aadhaar number, whatever it be, the number is not going to have, or any serial number is not going to have negative values. So, in those cases the negative values can be avoided by just making it as unsigned short int. So, unsigned short int, the range of data is going to be from 0 to 65,535. If I am declaring the data type to be int, int can support again with 16 bits, but here the 16 bits altogether it is an integral representation of the data type. The same int can even be made as unsigned to support again only the positive numbers. So, these are the ways that an integer basic data type can be modified using the modifiers, and according to the requirement we will be able to declare the variables. The integer data type can be increased with its range by declaring the modifier to be of long type. Say for instance, the long type can have the values from more than 32 bits. So, if it is more than 32 bits, we can go with the numerical range of 2 power 32 divided by 2. So, 2 power 32 divided by 2 will have on negative as well as on the positive range. So, on the negative range it can start from minus this value to positive this value. However, if we want still the range to be increased, still the range is not sufficient for me to do scientific applications, I can even still more modify that with unsigned long int. So, if I make it as unsigned long int, the division category will be eliminated and we will be able to get the range from 0 to 2 power 32 values. So, this is how the basic integer data types can be increased in its range of values to handle larger numbers and larger scientific or logarithmic values. So, this is how we will be able to solve the problem of handling the basic integer type to extend it to the range which we require for larger number applications. And the floating point type. So, generally the floating point type will again have 3 types of declarations. We can go with float, double and long double. The float type will be having 32 bits as the basic size. So, starting from it can have the data ranging from 0 to 2 power 32. A double can have up to the maximum of 64 bits, and so that we can have the floating point values from 0 to 2 power 64. A long double can even more be greater than the size of the double, but whatever be the data type size, it all depends on the size of the processor. If you buy a computer from market, the size of the processor, if it is of 4 bits, 4 bytes, the basic data type will be of 4 bytes. If you buy a processor with 16 bytes length, then the basic float type will be of 16 bytes. Starting will be 16 bytes and then it goes to 32 bytes and then it goes to 64 bits. So, however, the processor size is getting increased, that much ever the data type size also gets modified. It depends on the processor size. So, char is the only data type available with C language to handle any sort of textual information. So, if at all if I want to store a character or a string, I may have to go for defining the variable as char. So, basic char type variable will be of 8 bits. So, what we can say, one character is stored with 8 bits. Starting from the alphabet A to alphabet Z, similarly the uppercase characters also we will be assigning the ASCII values for the representation of these characters, which generally ranges from 0 to 127 in this case. Because char representation will not allow any negative representation. So, generally we will have only positive values, and signed char is going to even include negative values. So, in case if it includes negative values for character representation, it starts from minus 127 to 127, which is of 2 power 8 again. And we can make it as an unsigned char by removing the negative value representations. By defining a char to be unsigned char, we are removing or we are not considering the negative values, and only the positive values are considered as the range. So, the range becomes 0 to 255, but the size of the char type is going to remain the same as 8 bits. Then now we will see how we are going to assign the values or to a variable. Now, we have learned about naming the variable, we have learned how to declare the variable, and on declaration of the variable what are the data types to be considered, and in that data type we have seen how the modifiers will be able to change the size and range of the value stored in a variable. Now, we will see how we are going to use those variables in our program. So, we will learn about assignment statements. So, assignment statement is used to assign a value to a variable. So, the general syntax of the assignment statement, it is variable equal to expression. So, the example given are say A equal to 10, B equal to 10.5 and C equal to the character A. But here one thing we have to remember is that before giving this assignment statement, I should have defined the variables of the corresponding data type. Say for instance, before using the assignment statement A equal to 10, I should have defined the variable A of integer type. Similarly, I should have defined B as float type variable, and then I should have gone for the assignment of its value to it. So, the same way the character also I should declare the variable, and then I should assign the value to the variable. So, this is what the prerequisite of an assignment statement. The variable should have been declared already before assigning a value to a variable. And coming to initialization statement. What is an initialization statement? The value to a variable can be assigned at the time of declaration itself. Say actually in the previous slide we have seen that int A, it is a single statement, and then A equal to 10, it is again the assignment statement. So, this statement it is called declaration, variable declaration, and this statement it is called assignment statement. Okay. So, what happens actually with the compiler in this statement is, it is assigning, it is creating a variable named A, and it is mapping the address to that variable. This is what is happening in the variable declaration statement. In the assignment statement, the compiler will be go in search of this address, and the value for that variable will be stored in that particular address location. So, this is what happens in the assignment statement, but we can combine these two statements together and we can call that statement as an initialization statement. So, in that case, so int A equal to 10. So, I can do the declaration part, int A is declaration part, and assigning value to variable as 10 is the assignment part. So, I am combining, I am merging these two statements into a single statement, which is now named as initialization statement. So, at the compiler side, what happens actually, at the time of variable declaration itself, it will be assigning the address, and immediately on assigning the address, the value to that variable will also be stored in the corresponding address. So, two operations are now linked together using a single statement. We are not here merging two statements, here we are merging two operations through a single statement. Okay. So, this is actually a good and interesting feature of C language, that at the time of declaring variable itself, it assigns the address, and on assigning the address, the value to the variable can also be stored in the corresponding memory location. This is actually an interesting feature with respect to C language. So, which can help us in lot of hardware related programs to make us easily access the memory locations. So, here the example what we have taken earlier. So, int a equal to 10, we have merged the declaration and assigning value to the variable a. Similarly, I have here merged the two statements, declaring the float type variable and assigning value to that float type variable, both are merged here. So, here the character declaration as well as assigning value to the character is now merged as an initialization statement. But see to that, we need to have stored the corresponding type of value to the variable. We will not be able to swap, say for instance, I cannot store int a equal to 10.5, which is wrong. We will again see what are the values that can be stored in what sort of data types in the later sessions. So, on summarizing this session, we have learned how the variables can be named by following the rules of identifiers. We have learned how to declare the variables based on the requirement of the application, requirement of the task. If the task says that you need this much data space and this much memory space, accordingly you have we can choose the data type and we can declare the variables. And the assignment statement is to assign values to a variable using the expression. Initialization statement is the merging process of combining the declaration of variable as well as the assignment statement. So, put together these two operations can be merged into initialization statement. Thank you for listening to this session. Thank you once again.